So hey guys, my name is Keshav Kumar and I'm going to present to my topic that is stacks and subroutines in microprocessor. So let's just get straight to it. So today's topic is stacks and subroutines. So we will discuss about what exactly are the stacks and subroutines, how exactly are they are gonna help us with to increase the efficiency in the microprocessor. So let's just move on to the slides. So to the introduction part. Here we are going to see that the stacks and subroutines that are present in a microprocessor, how they exactly help a microprocessor, a program to increase its efficiency, to get a better throughput in overall program. So in this presentation, we will discuss the importance of stacks and subroutines to increase the efficiency. So let's move on to the next slide. So what are stacks? Stacks is a special area in a memory used by the CPU to store register information or general data information during a program execution. So what exactly happens is whatever operation you are going to perform on whatever opcode you are going to perform, the data gets stored in a stack that is in order of last in first out, where the last item stored is most usually the first one to get out of the stack. It's basically a push and pop system. So the last one in is the first one out to come. So a stack is a region of memory that is used to store data temporarily. The data needed for the execution of a program comes in a stack, and whenever it is needed to be used, it comes out of the stack, and then the execution is performed on those data. So in a stack there is a term called stack pointer, which points on the top part of the stack where the data is at the top. So the stack uses push and pop functions, where push means to insert the data in a stack and pop means to extract the data from the stack. So let's move on to the next slide. What are subroutines? Subroutines are reusable blocks of codes that can be called multiple times throughout a program. So while we have done coding, we are familiar to a term called functions. What are functions? Uh, Functions are a set of codes or a block of code that can be used multiple times, that can be called multiple times in a program, so that we don't need to write those lines of codes again and again to call the same to do the same function, to execute the same thing. So it's same as here. Subroutines are the reusable block of codes that can be called multiple times throughout a program, which can reduce the duplication time or duplicated codes. And while the duplicated codes are reduced, it drastically increases the modularity or efficiency of the program, which furthermore increases the efficiency in microprocessor. So for example, the sequence of micro operations needed to generate the effective address of the operand for instruction is common to all memory. The sequence could be a subroutine that is called from within many other routines to execute the effective address computation. So, in a microprocessor, the programs usually contains similar type of codes to execute. So, here subroutines really helps us to increase the efficiency and decrease the total time to compile the program. So let's move on to the next slide. The benefits of using stacks and subroutines. Well, the major benefit of using stacks and subroutines is that the time in the compilation of the program decreases, and there is an increase in efficiency of the microprocessor as as the lines of the code lines are less, so there are less functions to perform, which because they have already been performed in the past. And stack is really useful because they the stack is really useful because the data stored in the stack can easily be accessible by the memory. So these are the benefits which comes with the end result of that the efficiency of the microprocessor is increased. So some example of stack and subroutine, like there is a stack in 86 architecture to store return addresses and local variables. Another example is the use of subroutine in embedded system to control hardware peripherals. To control many peripherals, we use subroutine to give equal time or to schedule such input and output operations performed by the peripherals. These examples demonstrate the versatility and usefulness of stack and subroutine in microprocessing. So, in conclusion, the use of stack and subroutine is essential for maximizing the efficiency of microprocessor, because by using these techniques, we decrease the load on the memory, uh, because there are less lines of codes, and we also reduce the duplicated code, and we increase modularity. So there is a uh, increase in speed and efficiency. So this is the so thank you for listening to my explanation, and I hope you understand it. If there are some doubts, you can always pin me in the comments. Thank you.